about a substitution reaction. A substitution reaction can be electrophilic substitution reaction, can be nucleophilic substitution reaction, right? Over here, now if you see that whenever we are seeing a carbon, right? Whenever we are seeing a carbon, what we are seeing over here, we are seeing that here we are seeing that carbon and hydrogen, right? And we are having one halogen over here, right? Suppose X. So here what happens that if you replace a halogen, sorry, if you replace the hydrogen with a halogen, that will be giving you an enormous amount of what polar character, right? Isn't it? The halogen will be drawing the electron cloud towards itself, making this delta positive and making this delta negative, right? Now go to the next part, right? We also have to understand that whenever we are seeing this reaction, right, we can also have to tell that what will be the type of the reaction. Now, Ashvi, can you guide me that who will be attacking this? Who will be attacking this particular carbon? Can you tell me? If this electron density is pulled towards the halogen, right? In a halogen alkane, who will be attacking this per carbon? Can you guide me, Ashvi?
Wouldn't it be the positive?
This is carbon is positive over here, C positive. Who will be attacking over here? Who attacks? Nucleophile attacks or the electrophile attacks? What do you think?
The nucleophile.
Nucleophiles will be attacking. That's a very good answer and a quick one answer, right? Very good, right? So we are saying that the nucleophiles will be attacking, right? And what kind of reaction we undergo? We undergo a substitution reaction, right? And this particular group will be added. Can you see this? This group is added over here. So if you see a nucleophilic substitution reaction, the nucleophilic substitution reaction will be depending upon whether or not this carbon is primary, secondary, or tertiary. Now, can you guide me? Can you guide me, Eunice, that what is the primary carbon? Eunice, what's a
Is
primary
it
carbon?
a carbon that's bonded to 3 hydrogens?
Carbon which is bonded to at least two hydrogens, right?
At
At
least two,
least,
yeah.
right? At least two hydrogens, right? And that is called as a primary carbon. If you have got a primary carbon, right? A primary carbon will be undergoing a different path of nucleophilic substitution mechanism, right? Why is it so? Now we learned that when we learned that, Noor, can you tell me that what are the features of the alkyl group? Noor, can you tell me what are the features of an alkyl group? Alkyl group
Um,
is what? What does it do? Leslie, I will ask you next. Ashvi, next. You
Yes, sir.
tell. What are the features of alkyl group, Noor? That alkyl group will be having a, tell me,
um,
plus I inductive effect, right? Plus I inductive effect. Now Leslie, what are the other features of alkyl group? That if alkyl group will be having a electron pushing effect. Eunice, can you guide me that what do you mean by a plus I inductive effect? Can you connect a pen also, everybody, so that you can articulate on my board? Eunice, what do you mean by plus I inductive effect? Eunice? Plus I inductive effect means what? That if you see any alkyl group, right? Any alkyl group will be having an electron pushing effect, right? It pushes electron away from itself. Is it clear? Fine. Understood. It pushes electron away from itself. Fine. Did you get this thing? So if you having a alkyl group will be having a plus I inductive effect. Means it pushes away electrons away from itself. Eunice, is it clear?
Yeah.
Ashvi, is it clear?
Yes, sir.
And if you have got anything which is minus I effect, right? It will be pulling electrons towards it, right? Suppose you are telling L. L has a minus I inductive effect, so it will be pulling electrons towards itself. Got it? So any alkyl group which you are having, Leslie, Noor, Ashvi, you are having a methyl group, methyl, ethyl, propyl, whatever. It will be having an electron pushing effect, right? It will be pushing the electrons away from itself, right? So that's a very important part we have noted, right? It will be electron pushing away from itself. Second, now Leslie, what is the important feature of a alkyl group? Any other thing? First is it is having a plus I inductive effect, right? You need to understand this thing. What is the plus I inductive effect? Ashvi, got
Yes,
it?
sir.
Ashvi, understood. This is a very important part we'll be coming to know, right? For the mechanism part to handle. Now, tell me one thing, Leslie, that what are the other features
Are
of
they
alkyl group?
an alkyl group?
They are very much. Can anybody tell? Can anybody raise your hand and tell what is another feature of alkyl group? I'm going to Ashvi. Ashvi, can you tell me what's another feature of alkyl group that really changed the entire mechanism in a tertiary halogen alkane? See, I give you the hint also. It changes the mechanism of the tertiary halogen alkane. I told you also that what is the second feature of alkyl group. Ashvi, You tell me. I knew that you have got IAs to be done, right? So that's the reason I'm not telling you anything, right? That okay, study it. Eunice, can you tell me what's the another alkyl group feature? What's the another thing about the alkyl group? That it will be Noor. Can you tell me? Noor, Eunice, anybody can tell. What's another feature of alkyl group? Tell.
But they're polar.
They are bulky. That bulky group. Understood.
Oh,
Ashvi, is it clear?
Yes,
Understood.
sir.
Eunice, is it clear that it is a very fat? It see obeys. We see there are many humans who are having obesity, right? So alkyl group has got a bad luck that okay, they are very much obese people. Understood? Clear? Did you get the thing, Eunice? What
Yes,
I'm
sir.
telling you, they will be having a bulky group, right? It will be having a bulk. It occupies space, right? In the bulk, so it will be a bulky group, right? Now going to this thing, now if you see, when we see a primary halogen alkane is an alkane which has got only at least two hydrogens atom, and hydrogen is very much small molecules, means small atoms, right? Isn't it? So here you are having alkyl group which occupies a bulk. Okay, in a SN2 reaction, what happening, that you'll be seeing that there's a vacant space over here, right? The OH group will be will be attacking, right, from the opposite direction, from where easily, because see there's a vacant space over here. The bullet can attack, right? And what happens? You'll be having that the CCl bonds breaks heterolytically, right? Fine, heterolytically. And when you're going from a SN2 reaction, it passes to a unstable transition state, right? Eunice, can you tell me that what you mean by transition state? Anywhere you read? Because I have not taught you earlier. What is transition state? Any sort of guesses? Eunice, tell me. A transition
Mm,
state is what? It's a theory,
is-
right? Isn't it? It's a
oh,
theory.
okay.
Means we cannot take out this from a reaction mixture, right? It's a theory where this bond is getting formed, beam bond formation, dot dot dot, and this dot 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 is what? Bond breakage. Understood? And and if you see a primary halogen alkane, it will be moving via a unstable transition state. So in our last session, we also understood that if you now connect with the rates of the reaction, right? If you see the rates of the reaction, in any rates of the reaction, we know that the rate of a reaction will be what? The rate of the reaction will be equal to what? The rate constant into the Rx over here, right? Rx over here to the power of 1 into OH minus 1 to the power of 1, right? So we know that the rate expression for any reaction will be the rate expression of the slowest step, right? We know this. Rate expression of the slowest step. So we're getting it, right? The rate of a chemical reaction will be equal to the rate expression of the slowest step, right? Isn't it? And we know that this is the order of the reaction 1 plus 1, that is equal to 2. So the overall order of the reaction will be 2, right? The total order of the reaction is 2. So thus it is SN2. Now, Ashvi, can you tell me that which is the reagent we use? Do you use a do you use a protic solvent or a aprotic solvent over here? Ashvi, can you guide me?
A protic.
Aprotic solvent, right? Brilliant. Why so? Why do we use a aprotic solvent? Leslie, can you guide me? Why do you use a aprotic solvent, not a protic but a solvent? Why? Why use a aprotic solvent? Now, Leslie, can you tell me that what is a aprotic solvent? Leslie, tell me. What do you mean by aprotic solvent? Noor, can you guide me? What do you mean by aprotic solvent?
Does it mean that it doesn't do like it doesn't have hydrogen bonding?
Yes, very good. You recall that, right? Something like that, right? What are aprotic solvents? Aprotic solvents are solvents which do not form hydrogen bonding, right? With a solute, right? We learned earlier that whenever we are having a solvent, right? A solvent and a solute will be forming an intermolecular force of attraction, right? Right? Is it clear? Eunice understood this thing. They'll be forming an intermolecular force of attraction. It can be hydrogen bonding. It can be dipole-dipole. It can be London dispersive forces also. But a solvent will be always forming an intermolecular force of attraction during solubility. What is the aprotic solvent? Aprotic solvents are those solvents which do not form hydrogen bonding, right? Means what? That solvent itself will not have hydrogen connected to fluorine, oxygen, or nitrogen, right? It won't have. It won't have. any hydrogen connected to fluorine, oxygen, or nitrogen. Now, you Ashvi, can you tell me H2O is a aprotic solvent or a protic solvent? What's a protic solvent? A protic solvent is a solvent which will be dissolving a solute by formation of hydrogen bond, right? That's the intermolecular force of attraction. Is H2O a aprotic solvent or a protic solvent, Ashvi? Can you guide me? What is a aprotic solvent? A aprotic solvent is a solvent which do not form a hydrogen bonding with a solute particles. So my question, that aprotic solvent will not have hydrogen connected to fluorine, oxygen, or nitrogen. Is H2O a aprotic solvent or a protic solvent, Ashvi?
Protic.
Protic solvent. Brilliant answer. That's a brilliant and fast also, right? Very good. Amazing. So we will not use a protic, we will not use a protic solvent, because if you use a protic solvent, Eunice, what happens? This is the main reactive species, right? A protic solvent will be immediately surrounding the OH minus group, right? Isn't it? This immediately surrounding it, right? Thus will be what? Thus will be hindering it to attack the carbon, right? So thus we know that if you see that whenever we are talking about SN2, a SN2 reaction will be undergoing via aprotic solvent. Now come to SN1 mechanism. Now over here, Ashvi, this carbon is primary carbon, secondary carbon, or tertiary carbon? Ashvi?
Primary.
Primary
Sorry, no,
carbon,
secondary.
secondary. What is the secondary carbon, Ashvi? A secondary carbon is a carbon which has got only one hydrogen attached, right? One hydrogen attached, right? Is it clear? Which carbon you are trying to think about, focus about over here, Ashvi? Which carbon?
A central carbon.
Central carbon is attached to the substituent or the function group. Now over here, Eunice, how many hydrogens are attached with this, Eunice?
None.
None, zero. So now, if zero hydrogen is attached, Noor, is it a secondary carbon, primary carbon, or tertiary carbon?
Tertiary.
Tertiary carbons are those carbons which will be having no hydrogen attached, right? Fine, isn't it? Ashvi, is it clear? And a secondary carbon atom is a carbon which has got only one hydrogen. Ashvi, only one hydrogen, isn't it? See, if this was the thing, now this was a secondary carbon, right? Fine. So a tertiary carbon atom is a carbon atom which has got no hydrogens attached, right? Now go to the next part. We have to also see that when you see this reaction, in the earlier reaction, we are seeing what? The OH minus, right? The OH minus was attacking from the opposite direction because it had the space to attack. But whenever we are seeing a particular tertiary halogen alkane will be having alkyl group, and alkyl group will be having a very bulk, right? It occupies a bulk, I told you, right? Occupies a bulk. They're obese people, right? So will OH minus be able to attack over here in this direction? No. OH minus cannot attack, right? So that's a very important part we learned, that OH minus cannot attack. And thus, this will not be able to attack from the opposite direction, as we did in SN2. So the first step is what? The first step is that the Cl minus will be leaving heterolytically, right? Will be heterolytically. Ashvi, can you just tell me that there's only one reaction which occurs via homolytic bond breakage. The rest all other occurs via heterolytic bond breakage. Can you tell me that which reaction occurs via homolytic bond breakage only? Ashvi, can you understand my question? There's only one reaction which occurs via homolytic bond breakage, right? Bond breakage. Rest all others are heterolytic bond breakage. Can you tell me which is the reaction which occurs via homolytic bond breakage? Rest all other reactions occur by heterolytic bond breakage. Can you tell me? Homolytic was what? Only one reaction occurs by homolytic. Whom to ask? Leslie, can you tell me which reaction occurs via homolytic bond breakage? Rest all other reaction occurs via heterolytic bond breakage.
I don't know if it's right, but is it like
Think homolytic is what? That it leads to generation of free radicals, right? Understood? Free radicals. I've given you more hint, much more hint. Can you tell me the answer now? Homolytic bond breakage. I'll be coming to everybody now, right? Fine. I'm coming to Noor. Noor, which reaction undergoes by homolytic bond breakage?
Is it like electrophilic substitution?
Think. We have really done it. I'm coming to Ashvi. Ashvi, any guesses? Homolytic bond breakage, which also is equal bond breakage, right? And it resulted free radical species. Eunice, can you guess which reactions occur via homolytic bond breakage only?
Is it free radical
Yeah, free
substitution?
radical substitution. Brilliant, right? Amazing. Let's give a clap, right? Brilliant. Is it clear, everybody? Free radical substitution is only homolytic. Rest all other will be heterolytic. Means there will be uneven bond breakage, right? Uneven bond breakage. So that's a very important part we learned, right? So this will be what? This will be having tertiary, and OH minus cannot attack. So the first thing is that the Cl minus will be living heterolytically, right? It lives heterolytically, giving rise to what? A carbocation. There we have got what? In the earlier SN2 we have got there a unstable transition state. Here we are getting a carbocation, right? Now the most important thing you have to understand, that most weakest species is what? The most weakest species over here is the carbocation, right? Carbocation, because the carbocation will be immediately joining with the Cl minus and going back to the halogenalkane, which we do not want, right? So more stable is this carbocation, more will be the reaction happening, right? Now we know that alkyl, that somehow we can reduce the positive charge on this, right? Somehow we can reduce the positive charge. That helps us, right? That helps us. So if we somehow reduce the positive charge, that will be helping us to lower down the charges, and that will making this carbocation more stable. So we know that if we have alkyl group will be having electron pushing effect, right? It pushes electron, see? It pushes electron. So it will be lowering down the positive charge, making this more stable, right? Fine. And see, in the next step, what happens? The OH minus group will be attacking over here, and we are getting the substitution reaction. So can you see this in a SN1 reaction? What happens? You'll be having that the Cl minus and the OH minus will be leaving and attacking from the same direction. Number two, over here, Ashvi, can you tell me that what will be the rate expression for the entire reaction? Ashvi? The rate expression will be the rate expression of the slowest step, right? Will be rate expression of the slowest step. Now, can you tell me, everybody, if somebody help me to update the Excel sheet, I'm requesting you. I need that Excel sheet, right? I have to make sure that going forward, I'll be covering those parts which you have done earlier. Please copy paste the WhatsApp messages. I'm requesting to you, everybody. And whatever is done in your school, that also update it. Challenges, update it. Get the best out of the thing of the past papers doing that, right? Write down the challenges part. Now, Hashfi, what is the rate expression of this entire reaction? Tell me. It will be the rate expression of the slowest step, right? Slowest step. Which is the slowest step?
The top one.
Top one. Now, can you write down the rate expression, Hashfi? How to write down the rate expression? Tell me. How to write down the rate expression, Ashvi?
Isn't it like R?
Right. Rate is equal to Ka. Tell me. And Rx to the power of 1, isn't it? That's also.
Yeah.
Rx to the power of 1. Now, what is the order of the reaction, Noor? Can you tell me what's the overall order of the reaction?
1.
1. So, Eunice, is it a SN1 or SN2 we speak? Tell me, Eunice.
SN1.
SN1, brilliant answer, right? Everybody, right? This is a SN1 reaction. Now, SN1 reaction, we have to see that this occurs via a protic solvent. We have to take a protic solvent, right? Why? If you take a protic solvent, you know what? Now, which is the most unstable species in this reaction? Leslie, can you guide me? The most unstable species in this reaction, which you have to stabilize it. The most unstable species, can you tell me? The carbocation, this one, right? This is the most unstable species. So we saw that if you have got a tertiary if you have got a tertiary alkyl groups, right? So it will be pushing electrons away, reducing the positive charge. Second is that if you have got a protic solvent, the protic solvent will be surrounding this carbocation, reducing the positive charge. See, this is delta minus, right? All are delta minus over here. Delta minus, delta minus, delta minus, delta minus. So this will be reducing this positive charge further. And hence what we see, hence we'll be getting what? Hence we'll be seeing that it will be giving you a much more amount of lowering of the positive charge, right? Fine. So this is a very important part we learned, right? Now going to this part, if you compare the rate of the reaction, over here we have to understand that if you have a tertiary halogen alkane, right? If you have a tertiary halogen alkane, that will be the fastest and a primary will be slowest. On top of it, if you see that a tertiary halogen alkane, right? Suppose we are having a tertiary fluorine, right? Halogen alkane, fluorine, bromine, right? You've got iodine. Now over here, Ashvi, can you tell me that which will be the fastest? Fluorine, bromine, or iodine? Which will be the fastest? Ashvi?
Fluorine.
Fluorine, you said. What about you, Noor? Can you tell me which is the fastest over here?
Fluorine as well.
Fluorine as well. Ashvi, wait, hold on. I'm asking Leslie. Leslie, which is the fastest of this? If you're having tertiary fluorine, tertiary halogen as bromine, tertiary as iodine. Now over here, now I'm just giving a Eunice, can you tell me which is the fastest among these? Fluorine, bromine, or iodine?
The maybe iodine,
Iodine, you're saying. Why it is so? Eunice, tell me why it is so.
because the bond enthalpies.
Bond breakage, right? You meant to say, right? Everybody hear what he's saying, right? Very good answer. See, ultimately, this is bond formation happening, right? And this is the bond breakage which has to happen over here, right? This bond has to be breaking, right? So bond breaking takes what? Takes energy, right? It is endothermic, right? Fine. Now, Ashvi, tell me, which bond is the weakest? CF or CI? Ashvi?
Yeah.
CF, which bond is weakest? And how do you tell about the weakest bond in a particular covalent compound? Ashvi, you seeing that? What? The electrons will be if the electron pair is closer to the shared pair of electron, the nucleus, and in CIF, what happens? CF is this. This is CF. In CI, what happens? CI is this, right? CI is
yeah.
this, right? CI is this. So where will the bond be weakest? Ashwi?
Yeah.
CI and Leslie, can you tell me where will the bond be weakest? Tell me. Leslie.
In CI because there's
CI.
more
Why?
distance.
Because Noor understood. Noor, you got it. The nucleus, Noor understood. Nucleus is far away from the shared pair of electron. It's easier to break, right? Fine. Now remember one thing, that when we talk about SN1 and SN2, from the graph also we can tell, right? Our SN2 reaction will be having a single hump graph. Our SN1 reaction will be having a double hump graph, right? And SN1 reaction will be moving via carbocation, and SN2 will be moving via transition state. Now we are coming to the next part, which is the alkene reaction, right? Alkene. Now, can you guide me, Ashvi, that why is a alkene more reactive than an alkane? You tell me why?
Because the carbon-carbon double bond makes it more unstable.
Yeah, carbon makes it unstable. Why so? Why so, Leslie? Can you tell me? Can you just carry on from him? That he said a very important word, right? The
Because
carbon double bond.
is it because there's a lone pair of electrons around the double
No,
bond?
not lone pair. This pi bond is what? A weakly held bond, right? A pi bond will be in the pi bond, what happens? The electron density is above and below the plane, right?
Yeah.
Far away from the nucleus. Understood? Noor understood this thing. Ashvi understood.
Yeah.
It will be far away. A pi bond will be far away from the nucleus, right? In the nucleus, right? Plane of the nucleus. Thus, it will be what? It will be having a much more less grip, isn't it? In a sigma bond, what happens? In a sigma bond, the electron density is what? Here, in between the two nucleuses, right? Isn't it here? And
Yeah.
thus the nucleus can easily held on to a sigma bond more strongly. So a pi bond will be loosely held electrons, right? Loosely held in between the two nucleuses over here, right? Isn't it? Fine. The term breaks have started. Make sure
Yep.
that you grind now, right? 3-4 weeks earlier chapters, please grind, because you are having IAs, biology IA, or whatever means physics IA. So you have to submit all this, right? So that's the reason. Please speed up now. The earlier part will revise. Now, if you see a alkene will be much more reactive because it has got a pi bond, right? A pi bond does what? A pi bond is a loosely held electron cloud, right? And thus what happens? It will be loosely held. And this will be the site of reactivity, a pi bond, right? If you see a pi bond will be a site of reactivity because you're having what? You're having a loosely held electron cloud. And over here, Ashvi, now Noor, who attacks a pi bond is having electron density. Does electrophile attacks or nucleophile attacks? What do you think?
Electrophile.
Electrophile. What about you, Ashvi? Do you agree with her?
Yeah.
Okay. Eunice, what do you think? Do you agree with her that
Yeah.
electrophiles will be attacking? Leslie, you also do?
Yeah.
Thank you so much. Thank you so much. Yes. So electrophile will be attacking, right? And it will be attacking the loose real electron cloud over here, right? And thus, what we'll be seeing? We're seeing an addition reaction occurs, right? So this is the thing we are seeing, that if in our SL part we already did this, that whenever we are seeing a pi bond, right? Pi bond, it will be attacked by what? It will be attacked by X, Y, like this, right? X goes over here, Y goes over. Let me draw it quickly, right? Over here, X and Y. So X goes over here and Y goes over here. And what happens? This bond breaks and this bond breaks. What do you get? We get X and Y over here, right? And a what? And a addition reaction occurs. This reaction occurs via a heterolytic fission, we know, right? Heterolytic fission, right? Now, coming to the next part, right? Whenever we are seeing that electrophilic addition reactions, in your exams, there will be two kinds of electrophilic addition reaction which will be there, right? Two kinds of electrophilic addition reaction. The first will be that you're adding bromine, or chlorine, or fluorine, you're adding, right? To a double bond, which will not be polar. I'm giving the biggest hint. That bromine, see, is it polar? No, non-polar. Chlorine, is it polar? Non-polar. Fluorine, is it polar? No, non-polar, right? Is it clear, everybody? So whenever we are seeing, that the chlorine, bromine, fluorine, these are non-polar, right? In any electrophilic reactions, you have to show the generation of electrophile, right? As Noor said that, okay, you're having a pi bond, so electrophile will attack. But you have to show to the examiner, right, that the electrophile is getting generated, E plus. Bromine is neutral. How can it be Br plus, right? That is the most important thing we have to understand. That how can a Br plus be generated? That you have to show also, right? That the Br plus is actually generated, right? Now over here we have to see that when we utter the word, that the Br is attacking, how does it attack? Now here what happens? A sort of a instantaneous dipole happens, right? Over here what happens? Whenever this pi electron cloud comes to form a bond with the bromine, what happens? Now listen to this. The pi electrons will be repelling the nearest bromine's electron away from itself. Guys, is it clear? What happens? Noor, is it clear? Eunice, is it clear?
No,
What
sir.
happens? No, fine. What happens? Please stop me whenever. See, when this pi electron cloud, is coming to form the bond with this bromine, right? Isn't it? Bromine. What happens? You have to show that this is a electrophile, isn't it? You have to show this is the electrophile. This pi electron cloud will be repelling the nearest bromine electron away from itself. Noor, did you understand now? What did you understand?
Mhm.
Please
Yeah.
guide me.
You said that basically the electron density in the double bond
Mhm.
will be attracted to the nearest bromine atom, which will then repel the other bromine atom.
So what did I tell you? The pi electron cloud, when it starts to form the bond with the bromine due to the addition reaction, right? The pi electron cloud of the pi bond will be repelling the nearest bromine electrons further away from itself, right? Making this temporary delta plus and making this temporary delta minus. Understood this thing? What I'm saying? When the pi bond approaches to form the electron bond, the pi electron cloud will be repelling the nearest bromine's electron density away from itself, making this delta plus and making this delta minus, right? Once it is temporarily formed a delta plus, that's all it needed, right? That's the trick which is needed, right? Immediately what happens? These two electrons will be forming a bond with this bromine, and this Br bonds breaks heterolytically. Is it clear? Fine. Do you guys think? Can you guide me, Eunice? Can you read this loudly? You this loudly from here to here.
Bromine is a non-polar molecule, but as it approaches the electron-rich region of the alkene, it becomes polarized by electron repulsion.
Mhm.
A bromine molecule is polarized by an alkene. The bromine atom nearest the alkene's double bond, shown in here red, gains a positive charge, a delta positive charge, and acts as the electrophile. Note the curly arrow is always drawn in the direction in which the electron pair moves. The bromine molecule splits heterolytically, forming Br plus and Br minus, and the initial attack on the ethene in which this sigma bond breaks is carried out by the positive ion
Yes,
pi
yes,
bond,
pi
sorry.
bond breaks. No worries,
Pi
no
bond,
worries.
sorry.
Is it clear? Did you understand this thing, everybody? No, did you understand now? Leslie, do you understand this thing? What happening? BRBR is non-polar, right? BRBR is non-polar. Non-polar, 3.2 minus 3.2, 0. How could it form an electrolyte, right? How can you form a E plus, right? How? What trick? This pi electrons which is coming to form the bond with this nearest bromine will be repelling the electron cloud further away, right? Giving it temporary delta plus. Ashvi, is it clear? And
Yeah.
giving it temporary delta minus. Once the temporary delta plus delta minus happens, immediately what happens? This bond forms. And this bond breaks heterolytically, right? So what happens over here? The first step is what? The first step is that the pi bond will be coming over here and will be attacking over here and pushes the electron cloud, making it delta plus. Immediately it forms a bond. And this bond breaks heterolytically and we are getting Br minus. Now we are getting what? We are getting a carbocation. Once the carbocation is formed, the next step is what? The Br minus will be coming and attacking over here, right? Isn't it? And will be forming the second substitution. Understood, everybody? Clear? Ashvi, is it clear? What happens?
Mhm.
Fine. Is it clear to you? Ashvi, is it clear?
Yes, sir.
Leslie, is it clear? Leslie, please come back. Leslie, are you okay?
Yeah, I understand.
Thank you. Ask me any questions. Noor, understand what happened? You have got a little bit of challenge because it's non-polar, isn't it? But you have to show delta plus. Anywhere you have got electrophilic reactions, addition, substitution, anywhere, you have to show the generation of electrophile. That's the most trickiest part. In benzene, electrophilic substitution, yes, we have to show EP plus, right? You have to show, right, E plus. Has benzene electrophilic substitution been done in your school?
No.
Acha, fine. Ashvi?
No, no.
Eunice, has benzene electrophilic substitution reaction done?
Yeah,
Yeah, fine. Who has done this? Mr. Wells.
Yeah.
Please update the Excel sheet. I'm requesting to everybody. Yeah? Everybody requesting to you. See, now second is what? It's very easy now. We have got HBr. Now, Noor, is HBr polar or non-polar, Noor? How do you find out a polarity, Noor? First tell me.
You
What trick did I tell
subtract
you?
the
You subtract the
electronegatives.
electronegativities. That's all. Very good answer. Clap. Wonderful. You have to subtract the electronegativities. That's all. 2.2 minus 3.2 gives you how much? 1. Yes. This is delta plus delta minus. Ashvi, is it clear? Eunice, is
Yeah.
it clear? How to find
Yes,
out
sir.
the molecule is polar? Simple. Go for electronegative differences. So here it's a case is easier, right? Not complicated as we had earlier. It's much more easier, right? Much more easier over here, right? Over
Wait,
here it's
sir.
much. Yeah, tell me.
You put 2.2 subtract 3.2 is 1. Will it not be negative 1 or does it really not matter?
No, we have to see that who is pulling the electrons. 2.2, this is 3.2. Who will be pulling the electrons? The
The BR.
electronegative difference is how much? 1. Who pulls the electron? Tell me. More
Oh, the BR.
electronegative. So this will be delta minus. Good question, Ashvi. Don't everybody take a leaf out of Ashvi. Right, going to your final exams, don't hold on yourself, right? Noor asked me that, hey, I didn't understand. Good. Everybody take Ashvi. Very good. Now you understood now? Ashvi?
Yeah.
Clear, everybody? This is a very important trick. Bonding triangle will be there in your exam, right? What's the thumb rule? 1.8, right? We know that if you're having electronegative differences, which is having greater or equal to 1.8, that substance will be ionic in nature. Understood? More 1.8 character, greater than 1.8, more ionic character. Less than 1.8, much less than 1.8 will be covalent character snipping in. Understood? Clear? Fine. So if you have a covalent molecule, we have to see that which is more polar by the electronegative difference. Now everything is easy over here, right? Now the pi electron cloud won't have to do that extra hard work as it did earlier, right? Isn't it? Isn't it, Leslie? Will the pi bond have to do a hard work which it did over here by
Yeah.
creating a delta, temporary delta plus, temporary delta minus? No,
No, it
it won't
doesn't.
have to do the hard work. Now it's a highway is almost clear, right? There's no traffic jam. See over here, highway is absolutely clear. So this delta plus will be attracted by the pi electron cloud. That's it. And heterodytic bond breakage will be there. While I check the board papers, I'm telling you everybody, don't try to put arrows like this, right? Like this, right? Please make sure, don't try to put arrows like this, starting from carbon to here. Never. Don't, right? Please, I requested everybody last session that send me the mechanism. I can guarantee you that 4 to 6 marker mechanism will be coming. Easy cherry pickings. You have to make sure that the easy cherry picking should be done clearly, right? So what happens over here? This pi electron cloud will be coming and attacking over here, right? And immediately what happens? This will be breaking down heterodytically. And a carbocation forms, right? Isn't it? A carbocation forms. Now, the next step is simple. Just see, guys. Don't forget to put the 2 electrons over here. Otherwise, it will be 0. Right? I'm just saying that where are the maximum mistake which I see, right? Is it clear, everybody? Got it, everybody? Fine. So what happens next? That the Br minus, this Br dot dot will be coming and attack over here, right? And we are getting a dibromo product, right? Fine. Now there's a question in your board exams, right? That can you tell me that suppose you're adding a alkene, we're adding a HBr to it. Now to this mixture, I'm adding a little bit of salt solution, NaCl. What will be the result? Guys, understood my question? I'm using what? Alkene, NaHBr, and I'm adding a little bit of NaBr, right? NaCl, salt, ionic salt solution, a pinch of salt solution, the test tube, right? What are the products obtained, right? Fine. So what I'll be doing, suppose we are seeing what? We are seeing that if we have a symmetrical alkene and an unsymmetrical alkene. If you have got a symmetrical alkene will be having similar kind of, this is the mirror image you have drawn. This is symmetrical, right? This is symmetrical. Now if I change this by CH3, this becomes an unsymmetrical alkene. On the other hand, if I write over here CH3 also, CH3, this is a symmetrical alkene, right? So when you're adding a species to an unsymmetrical alkene, right, then it will be following the Markovnikov rule, right? In the Markovnikov rule, we have to. I'm just giving a shortcut to you. That if you're adding Ashvi, is it a symmetrical alkene or unsymmetrical alkene? This
That is unsymmetrical.
Now, if you're adding a AB, if you're adding a AB to an unsymmetrical alkene, right? Suppose this is a positive part, this is a negative part, right? Fine. Now write down this quickly, the rule. If you're adding a AB to an unsymmetrical alkene, now write down that. The positive part of the species will be going to the, write down the positive part of the species, right? Species goes to the carbon, right? With more number of hydrogen, right? Fine. Is it clear, everybody? Have you written this? Noor understood this thing? Ashvi understood? Eunice, Leslie,
Yes, sir.
got it?
Yeah.
When you're adding AB, the positive part of the species goes to where? The positive part of the species goes to the carbon with more number of hydrogens. Having said this, Ashvi, now everybody text me where will A go? Or you can also tell me. Where will A go? Will A go to carbon number 1, Noor? What's your take? Or carbon number 2?
Uh,
A is the positive part of the species. Will it go to carbon number 1 or carbon number 2? What's your take?
carbon number 2. Actually, 1.
What did you understand about the trick I told you about that rule actually? That if you're adding AB to an unsymmetrical alkene, the positive part of the species gets attached where? Noor, tell me. To the carbon with, tell me, more number of hydrogen, isn't it? Is it clear? In carbon C1, C2, where is having more number of hydrogens? Noor? Where do we have
And
more number of
C2
hydrogens? Check.
and
Check.
C1.
C1 or C2?
C1.
You told both. C1 you told, right? So where will be the A plus going? Where? C1 or C2?
C1.
C1. Eunice, next your turn. See, we did go to C1, C2. Eunice, A plus will be going where? To the carbon with more number of hydrogens. Eunice, where will it go? Eunice, Eunice, can you hear me?
C1, sir. C1, sorry.
C1. Okay, no worries. Ashvi, what is the take?
C1, C1.
C1. Desle, what's your take?
C1.
C1. Is it clear, everybody? Clear? So this is called as Markovnikov rule. Just remember that if you have got a species added to a unsymmetrical alkene, the positive part will be going to carbon with more number of hydrogens, right? Now go to the next part, right? If you see when we think about this reaction, right? This reaction. Now over here, can you tell me that when you go down the group, right? When you go down the group, Ashvi, fluorine, chlorine, bromine, iodine, right? When we go down the group, right? Can you tell me, Ashvi, that is the electronegativity decrease or increase?
A decrease?
Decreases. So in BRCl, which will be the positive part?
Wouldn't it be, wait,
Which is more electronegative? That also you can tell me.
bromine?
When you go top to bottom, the electronegativity decreases, as you brilliantly said. It decreases. Electronegativity decreases. So which is the
Oh no,
more...
it's the chlorine. I'm sorry, the chlorine. No,
When you
the
go from
bromine
top
is
to
more-
bottom, the electronegativity decreases.
it will be bromine that's positive.
Positive, and this is negative, right? Now A and B. Now over here, Eunice, which will be the major product? A or B? Eunice? Which is the major product? A or B?
Would it be B?
Okay, you're saying B. Okay. And what about you, Noor? Did you answer my
B.
question? Okay,
B
B.
as well.
Leslie, you?
I can't lie, I don't understand what you mean by main product.
Okay, main product means that both the products will be obtained. This will be 80%, this will be 20%, right? Isn't it?
Yeah.
Who judges the major product? Leslie, can you tell me? Who judges the major product? Markovnikov rule. What's the Markovnikov rule tells you?
The
Leslie?
positive. It says the
The positive part of the
goes to most
species goes to
hydrogen.
what? Carbon with, tell me,
Most
more number of?
hydrogen.
Yes, more number of hydrogens, isn't it?
Oh, okay then.
Fine.
Yeah,
Isn't it?
B
Which is the
then.
major product? Tell me.
Is it B?
I'm not sure. Ashvi, which is the major product?
It's B.
B. Why? Ashvi?
Because the bromine, which is the more positive one, is is bonded to the carbon with the most hydrogens, which is the one on the left.
It will be bonded to the carbon with more number of, it will be going to the carbon with more number of hydrogens, right?
Yeah.
You need addition reaction occurs, right? When you're adding this, bromine will be going here, chlorine will be going here, and this bond breaks and this bond breaks, and we are getting this, right, as a major product, right? So that is all about what? That is all about the Markovnikov rule. I'll be giving a homework. Why? That will be very important. Now, Ashvi, send me a message, please. Explanation of Markovnikov rule to be done as an exam, to be self-studied. I'll be going through it. I'll be
Wait, so
going
what was
through
it? Explanation?
Explanation of MR, Markovnikov rule. MR is Markovnikov rule. Markovnikov rule, right? Markovnikov rule. MR. Expression of MR, page number 506. Ashvi, self-study, right? Fine. Then you send?
Yeah. Explanation of Markovnikov
Of
rule.
rule 506 PSN, self-study. I need all the mechanisms done by today. I don't know how. Today night,
Wait, so what
neatly,
page did you say? Page is
page 506.
506. Okay.
Is it clear? Noor understood this thing. Leslie understood?
Yes.
Now you have got your term breaks on, right? By today night, you will be sending me the mechanisms. I don't know how. Colored pens like this. Send the mechanism. Last week also I requested everybody, SN1, SN2 do. Now see, SN1, SN2 has piled up. But no worries, do it. It will be 4 marker, 5 marker there, 100%, right? Over there, right? Fine. All these. Send me a message, Ashvi. SN1, SN2. PSN old 498, SN1 SN2 comma E1 E2 498 page number
SN1 SN2 and then
E1 E2 E1 E2
E1 E2
PSN page number 498 to 498 to 508
pages 498
to 508.
508. Got it.
Fine. See, this will be coming in exam. Explain carefully why alkenes undergo electrophilic addition reaction. Outline mechanisms of the reaction between butene, see, butene and bromine, and name the proper. Butene is what? Myth. Butene is this. This is butene, isn't it? Now, over here, Eunice, is it butene which I have drawn, or do you agree? Eunice, is it butene
Yeah.
which I have drawn? Eunice,
Yes.
is it clear? Okay, fine. Is it a symmetrical alkene or unsymmetrical alkene?
It's symmetrical.
What about you, Ashvi? Is it symmetrical or unsymmetrical?
Symmetrical.
And what about you, Leslie?
Symmetrical.
And Noor?
Symmetrical.
Wow, good, isn't it? So we know that HBr or whatever I'm adding, it can go anywhere, right? Is it clear? Anywhere. That's not an issue. Is it clear? See, this is a very good question. See, ICl with propene, with eth-prop. Fine. Leslie, is it a symmetrical alkene or unsymmetrical alkene? Propene?
Unsymmetrical.
Unsymmetrical, that's a good thing. ICl you have added, right? ICl. Now over here, when you add ICl, now over here, Ashvi or Leslie, tell me, who is the positive part over here? Iodine or chlorine?
Iodine.
Very good. So iodine is positive, you are saying. So iodine goes where? C1 or C2?
We'll go to 1, 2.
It will be going to the alkene where
C1.
the carbon will be having more number of hydrogens, right? Isn't it?
Yeah, so C1.
C1. And what about you, Eunice? What is your take? Expert comment?
Yeah, C1.
C1, brilliant answer, everybody, right? Lovely. Got it. Is it clear, everybody?
Yeah.
Make sure that you do the mechanism. I folded hand, I'm telling you. You can go and ask Professor Arfan, 4 to 6 mark a question of mechanism will be coming. SN1, SN2, E1, E2, and benzene substitution reaction, which we'll be doing in the next session. Everybody is clear? Has benzene substitution reaction been done, Ashvi, in your school? This one?
Yeah, I'm pretty sure.
Leslie, Noor, what is your take? Has been done by any teacher?
I think it's been covered, but I don't think it was in much detail. It was just like
Okay.